Okay, so is everybody familiar with scientific notation?
Oh yeah.
Okay.
Yes, but like a refresher's nice.
Okay. Basically, it's just using powers of 10 as kind of a shorthand to represent really big or really small numbers, so that you don't have to write out a lot of numbers or zeros on either side of the decimal point.
It's actually spaces, because you got to be careful, because if you have something like 12.3 times 10 to the second power, you move the decimal 2 places. A lot of people want to add 2 zeros. So it's all about moving the decimal to the left or to the right. Sorry, I was a math teacher.
Well, you can add the zeros as long as you know how many to add.
Yeah, I know, but I mean, like if you've got values after the decimal that aren't zeros, like if you have, like 12.3 times 10 to the second power, you have to move the decimal 2 places, not put 2 zeros there.
Correct. So the basic things are 10 to the 0 power, which is actually equal to 1.
Anything to the 0 is 1, yep.
Right. Even if it was base 2, and we'll talk about base 2 when we talk about digital stuff later on. Yeah. 10 to the first power is obviously 10. The second power is 100, 10 times 10. 10 to the third power, which is 10 times 10 times 10, which is 1,000. And you go on up, multiplying by 10 each time. If we have a negative power, then it becomes a value less than 1.
Mm-hmm.
So 10 to the minus 1 is going to be 0.1, and 10 to the minus 2 is 0.01. So it's really the reciprocal of the positive power.
Mm-hmm.
And we use these a lot to, we talk about values of inductance and capacitance, things like that, which have a very wide range from, and we'll talk about the names of units from picos up to millis and things like that. And when we do conversions between things like kilohertz to megahertz and stuff like that, so some of these come into effect. So we tend to use these little abbreviations to represent some of these scientific values. So we use milli to represent 1,000th of a quantity. So in other words, a milliampere is 1,000th of an ampere. And that way we can represent it as just a, usually just little MA to represent a milliamp. It's a fairly common value. We use micro, and it's actually a little Greek mu sign, but most keyboards don't have it, so a lot of times it's just represented with a small u to represent a micro, like a microvolt, or a microhenry, or a microfarad. And it's 10 to the minus 6, or 1/1,000,000th of a quantity. We have nanos, which are getting smaller. It's a billionth, or 10 to the minus 9. And we use a small n to represent. We might have a nanovolt, or a nanofarad, or a nanohenry. We get even smaller with pico, which is a trillionth, or 10 to the minus 12. That's a very, very small amount of current if it's a picoamp. And we use a small p, so we'd have 1 PA. And normally, like on the milliamp, I think I showed it with a small a, it would be a little m with a capital A. When we start going the other way, for bigger numbers, we have a kilo. The significance is it's a small k. If you notice when we talked about the pico, the nano, the micro, they were all small letters. In the case of large letters, it's normally a capital. The K is an exception, and I don't know why. But it's actually a trick question on the exam.
Great. Thank you for the...
So we use a small k to represent a kilo, like a kilovolt. Could be a kiloamp. And that represents 10 to the third, or 1,000 of whatever the quantity is. Next is a mega, which is a million, or 10 to the sixth.
Megahertz.
We use megahertz a lot. We use a capital M and a capital H, little z, because hertz is an abbreviation for hertz, proper name. Giga is a billion. When we talk about UHF frequencies, we talk about gigahertz or a billion hertz, 10 to the minus 9. Some of the things that operate there is your cell phone. It's either on 2.4 gigahertz or 5.2 gigahertz. So here's a little chart showing the relationship of all of these, what the abbreviations are and the prefixes. Some examples of conversions. If we wanted to convert a value in amperes to milliamperes, just remember that there's 1,000 milliamps in 1 ampere. So to convert from amperes to milliamperes, you would just multiply the amount of amperes by 1,000 milliamps per ampere, and you'd get 2,000 milliamps if it was 2 amperes. If you were going the other way, if you had milliamps and you wanted to know how many amps that was, remember again, there's 1,000 milliamps per amp. So in this case, you want to divide. So you would divide the 100 by 1,000 milliamps per amp and come out with 1/10 of an amp. If we were doing hertz to kilohertz, it's the same kind of ratio. There's 1,000 hertz in a kilohertz. So we would divide, and it would be a 7 hertz would be equivalent to 0.7 kilohertz. And if we go the opposite from kilohertz to hertz, we have that same ratio. So in this case, we multiply, and kilohertz is equal to 2,000 hertz. If we're doing, let's say, voltages, and we want to convert microvolts to volts, remember there's 1 million microvolts in a volt. So in this case, we divide it because we're going to a bigger number. So we would come out with 0.00007 volts. We would normally just keep that in microvolts because it's a lot easier to write and deal with than saying 0.00007 volts. If we were going volts to microvolts, it's the same ratio, but we multiply. So 1.5 volts would be equal to 1.5 million microvolts.
Can I ask a question?
Sure.
I just want to clarify because this math kind of confuses me a little bit. So from going to volts to microvolts is going to a small. When you say so microvolts, we're going down in the chart. When we're going down in the chart, we multiply, and when we're going up into the chart, like if I were going to go to volts to or hertz to, like, let's say megahertz, I would be dividing. Like when I'm going up, do I divide, and when I go down, I multiply?
If you were going like microvolts to volts, you're going to divide.
Volts to volts. So when I'm going up, I divide.
And if you're going volts to microvolts, you're going to multiply.
Okay, microvolt.
Because there's more microvolts in a volt.
Okay.
Okay. In fact, there's 1 million of them. So that's why you multiply it by 1 million.
Got it. Cool. Thank you.
If we were doing watts, and we went from milliwatts up to watts, okay, because watts are bigger, okay, we're going to divide in this case. So we divide the 100 milliwatts by 1,000 milliwatts per watt, so that the milliwatts cancel out basically, and we get 0.1 watt. And going the opposite, we multiply. So half a watt would be 500 milliwatts, because 1 watt would be 1,000 milliwatts. When you start using these things, it just becomes kind of intuitively obvious. You don't have to do this multiplication and division.
It says gaining proficiency. We have no proficiency yet. We just trying to grasp the idea.
It takes practice.
It's slow.
So let's see. We did megahertz to kilohertz. In this case, we're going to a smaller unit, so we multiply. If we're doing kilohertz to megahertz, we're going from a small to a larger, so we divide. The same thing as for ohms to kiloohms. We're going to divide because we're going from a smaller to a larger, and in the case of kiloohms to ohms, we're going from small to large. So you use the same technique regardless of whether we're talking hertz or ohms or amps or whatever. You just have to remember what the relationship is between the two values. So in the case of like the megahertz and kilohertz, it's 1,000 kilohertz per megahertz. If we were going to go, say, gigahertz to kilohertz, it would be 1 million kilohertz per gigahertz. So you just have to remember what that ratio is between the two types of units.
And Robert, would I be right that they're on this test when you take the technician exam? It would be good to memorize the chart so you know the relationship. Like you can't have a chart. They don't give you a chart. You don't have a chart. You have to memorize the chart. Is that right?
Correct.
Okay, cool. Will do.
Well, we'll see how hard these questions are. Here's one. How many milliamperes is equal to 1.5 amperes? So remember, what's the ratio between milliamperes and amperes? There's how many milliamperes in an ampere?
A million.
No.
Right then.
A milli. Not a micro, a milli. It's from the Latin.
Memorized yet? Milli.
There'd be many, many more milliamperes
It's like
than
milli of them.
one. There are more.
Milli of them.
You'd multiply it by 10 to the third.
Yep.
Mm-hmm.
Okay, so that means you add zeros.
There's 1,000 milliamperes in an amp, or 10 to the third milliamperes in an amp.
So you move the decimal point over to the left.
To the right.
Right, to the right.
Which is it, left or right?
To the right, right, to the right.
There's none of them
To make
are
more,
letting
to
you
make
do
more
decimals,
of them,
yeah.
yes. So we need to add 10 to the third, which is 3 decimal places, yes?
Mm-hmm.
Math
Right.
teacher?
Yes.
Okay, so 1,500. Charlie,
Mm-hmm.
Well, let's see.
let's see.
All right.
Yay! It's tortured, but we got there.
So which is equal to 1,500,000 hertz? Here they don't tell you what the conversion is. You have to figure it out.
Well, let's see.
Oh, geez. You have to do the calculations for all of them.
Yeah.
Yeah.
Let's see. Well,
Okay. So,
Well, to find out about alpha, for example, you would divide it by it's going to be a smaller number
mm-hmm.
because we're dividing, so it's 1,000. So 1,500 is equal to that, and therefore Bravo can't be that. Oh, wait, yes, Bravo can't be that. I'll go for alpha. Although there might be more than one answer, right?
uh-huh. So you just move the decimal point 3 places to the left.
Yeah.
Well, that's okay for alpha, but it's not okay for Charlie.
Well, it gives you the answer though for alpha.
Yeah, but there can be
But
more than one
kilohertz.
answer.
Well,
Well, there's only
not really. No, because
one correct
hertz.
answer.
It can't be though. It's more than one answer.
Isn't that megahertz?
Well, it can't be
It's kilohertz.
delta either.
Be megahertz, that'd be 1.5. No. Yeah, it would have to
Right.
be 1.5.
It'd
So
be
it's gotta
1.5
gotta be-
megahertz. That's not an answer.
Nope. It's gotta be alpha.
I'm gonna go for alpha.
Mhm.
Yeah, yay.
That's probably the hardest one.
I find it
Which is-
for myself. I find it easier to go convert from hertz going up to gigahertz than going down, or going up in number, I suppose. But going down the chart, I find harder than going up.
Okay. Which is equal to 1 kilovolt.
Kilovolt.
And remember, a kilo, even though it's a small k, is 1,000 volts.
So we got the answer, Charlie. Yeah.
See if you were paying attention.
Yes, I was. That one's familiar though, because of kilobytes in the computer also.
Kilo is 1,000.
So which is equal to 1 microvolt. Remember, a microvolt is a small amount.
I think it's alpha.
What delta?
Did you read all 4 answers?
No. Maybe it's
Look at that. I'm looking at the chart again. It's many, many zeros. So
maybe it's delta.
yeah, I think you're right.
1/1000th of a volt.
No, many more. 1/1,000,000th of a volt. I'll say alpha.
I don't know.
Yep. Microvolt is a millionth of a volt, 10 to the minus 6. which is equal to 500 milliwatts. Remember,
Bravo.
how many milliwatts are in a watt?
1,000. 1,000. So bravo. Bravo.
Bravo, bravo.
Okay. Which is equal to 3,000 milliamperes. Remember, we just did milliamperes a little bit ago.
Delta.
Okay. What is the abbreviation for kilohertz?
Hmm.
Remember, I told you about a trick question.
I think it was delta. Yes, delta.
All right. Little k, capital H.
Little z.
What's the abbreviation for megahertz?
Delta.
Mm-hmm.
What's the which is equal to 3.525 megahertz?
Mm. Charlie.
Charlie.
Yeah.
Very good. Which is equal to 28,400 kilohertz.
Mm-hmm.
Delta.
I think it's alpha.
Delta. Which is equal to 2,425 megahertz. And they want this in gigahertz.
Oh.
Remember, a gigahertz is
Like 9 billion.
10 to the ninth. A megahertz is 10 to the sixth.
Charlie.
Yep.
All right.
I just wanted to say to everyone that in the manual, the study guide that Robert sent us,
Mm-hmm.
on page 17 is the chart that says what a giga, mega, kilo, milli, micro, nano, and pico are. In case you're interested in
That was one of the
referencing it.
slides, I think, wasn't it?
Yeah, but the slide isn't showing, and because I went into it on my tablet, I can see the chart, which has made me much smarter than I would have been, just to say.
Which is equal to 1 million picofarads. Remember, we said a picofarad was
like a negative 12.
10 to the minus 12, right?
4 to 6. 1, 2, 3. Ooh.
Take away.
Oh,
shoot. This one's like micro.
6.
You have to take away all these zeros and another 6.
Say B.
So I took it to 1, but to get to micros,
Mm-hmm. Say Bravo.
so you only have to take away 6. I go for Bravo.
That's what I am.
Very good. Okay, now some fun. We'll talk about decibels. And we use decibels a lot to represent ratios of things. It's another one of these kind of shorthand things, like scientific notation. It was first developed by AT&T as a way to measure transmission line power on their long line telephone lines. And of course, being, a telephone company with Alexander Graham Bell, they started off and they called this thing a bell.
Of course.
And discovered that it was really too big a unit. So they downsized it to a decibel, which is what we use today. And a decibel is defined as 10 times the log base 10 of a ratio. P2 over P1 if it was power. Say power, P2 is the power out, P1 is the power in. So if P2 was twice as big as P1, then it would be 10 times the log of 2. And it just turns out that the log of 2 is 0.301, so 10 times that would be 3 dB. And that's one of the main things you need to remember is a ratio of 2 is 3 dB.
Put a little star down on my page here, a ratio of 2.
And
3 dB, 3
if it's a
dB.
positive ratio, you're going to come out with a positive number. If it's a negative ratio, you're going to come out with a negative ratio. I should say negative ratio. If the ratio is less than 1, the value will be negative. In other words, if it was 1/2, then it's going to be minus 3 dB.
Gotcha.
So if the ratio was 4, it's going to be 6 dB. If the ratio was 10, it's going to be 10 dB. If the ratio was 100, it's going to be 20 dB. So you can probably see where that's going. And when we go with the smaller numbers, it's kind of the same way. You're going to get a -3 or -6, a -10, a -20, a -30.
When you say, I'm just curious with the log part, what does that number represent?
The log?
Yeah, 10 log 10, and then, yeah. It's been a while since I've used that.
A long time for me too.
A long time ago, somebody sat down and created a table of, quote, logarithms, which is really what power you have to raise a number to equal that.
Okay.
So in the case of
So is that what we're figuring out? That ratio of 2, a ratio of 4, a ratio of 10? Is that the logarithm?
No, the logarithm is the power you would have to raise that ratio to, okay, to get the number. In case the ratio of 2, okay, the log of that is going to be 0.301. What that means is if you raise the 10 to the power 0.301, it's going to be equal to 2. So that's all the logarithms are. Is what power. And somebody sat down, like I said, years and years ago and worked all these things out, and they created these. You used to be able to get them in a book of logarithm tables. You could look it up. Now it's on your calculator.
Yeah, same thing with trig.
Which is why we don't know what the heck it is. Just to say.
Now, you notice there's two different formulas there. Well, three.
Mm-hmm.
For power, it's 10 times the log, because power is the squared function, because it's multiplying voltage and current things. And if we were doing it on voltage or current, it's going to be 20 times the log. And that's really the difference. So it's just a shorthand, and we use the dB with a small d and a capital B because of Bell. And a lot of times you will see it, depending on what we're measuring, against some reference, you'll see it as dBi, for instance, dBd, dBm, dBv. What those mean is dBi is you're measuring usually antenna gain relative to an isotropic radiator, which is this little imaginary point source antenna that is used as a reference. If it was dBd, then you're measuring it against a dipole antenna. If it was dBm, you're measuring it against 1 milliwatt, which is kind of a standard power reference for radio signals. And if it was dBV, you're measuring it relative to a volt. We don't deal with that much. There's a conversion between dBd and dBi, where 1 dBd is 2.15 dBis, because the dBi is a imaginary antenna. Because if you had this point up in space that radiated in a complete sphere, that would be an isotropic radiator. You can't really build one. A dBd is a physical dipole, which we'll talk about it when we talk about antennas. That's kind of the most basic antenna is a dipole. So any questions on dBs?
All right.
The ratio of 2 is how many dBds?
3.
Just 3, but not like 3.01 or anything like that, right?
Well, yeah, it's actually 3.01, but
okay,
we round it off to 3.
Right, yeah.
Yeah, I don't quite understand it, but I'll memorize
I'll go with it.
the ratios.
You only have to remember a couple of these. You don't have to work the formula. At least not until you do the general.
Mm-hmm.
So the 3 dB
it's coming.
6 dB is 4 to 1. 10 dB is 10 to 1. Minus 3 dB is 1/2 or 1 to 2. Minus 6 is 1 to 4. And minus 10 is 1/10. So if you know those, you're good.
Okay. Yep.
Now, the other thing about dBs and why they're useful is you can add them together, which is the same as multiplying the basic number. For instance, if I add 10 dB and 3 dB, for 13 dB, it's equal to 20. Because I've got 10 dB, which is 10, and 3 dB, which is 2. When I add the dB, it's the same as multiplying 10 times 2. So what decimal value, excuse me?
And that's different than the question that's actually on the screen right now.
Yes.
Correct. Okay, great.
Blow your mind a little.
Great.
What decimal value most closely represents a power increase got this thing away, from 5 watts to 10 watts?
Bravo.
Bravo.
Bravo. What decibel value most closely represents a power decrease from 12 watts to 3 watts?
Charlie.
Negative
Charlie.
Charlie. Charlie.
Which decibel value most closely represents a power increase from 20 watts to 200 watts?
Alpha.
That's what I'm saying. And I can't change my mind.
Very good. Yeah, there's the chart with comparing the prefixes and stuff. And the formula for decibels and what the conversion is between dBds and dBis, which we'll be using when we talk about antennas. So that's all there is for that one. So there'll be one question out of that group. You might get a dB or you might get one of the other ones. Conversion. They're not hard.
Just have to memorize it.
Got to know. It's all not hard if you know it.